me open this. All right. Let's look at this from the very beginning, okay? It says yada, yada, yada for these questions. Maybe we'll do B. B is the hardest one there.
Okay.
It says determine the domain range intercepts, and then we also got to do it for the reciprocal function, okay? So we're doing for B. So the main function is just f of x, yeah? Equals 2x squared plus 7x minus 4. And then the reciprocal function is going to be 1 over 2x squared plus 7x minus 4. So what is the domain of this function? So this is a quadratic, right? What's the domain of a quadratic function? That means what are the possible x values a quadratic can take, right? Quadratic looks like this, you see? It's infinite. X can be anything for a quadratic.
Yeah.
Also for a linear, x can be anything. Now what's the range of a quadratic? To find the range of a quadratic, yeah, you need to find its vertex.
Okay.
How do you find, so right now this quadratic is in standard form. We got to take this into vertex form. Any ideas on how to do that?
I honestly haven't done that in a while, so if we could like go through that together.
Sure. So the vertex of a quadratic is HK, okay? To find h, if it's in the standard form, that's going to be minus b over 2a. Here, if you compare this with ax squared plus bx plus c, you would get a is 2, b is 7, c is minus 4, yeah?
Yeah.
These you'd also use for the quadratic formula, but we don't care about the x-intercepts. We want to find the vertex, yeah? So minus b over 2a, that's going to be minus 7 over 2 times 2. So minus 7 over 4, and I think that's minus 1.75. Minus 7 divided by 4, yeah. So that's the x value of the vertex. To find the k value of the vertex, the y value of the vertex, you just got to plug this back into the equation as the x value. Okay, and that's how you find the vertex. You gotta, or the range, you gotta change it into its vertex form. So 2 times minus 1.75 squared plus 7 times minus 1.75 minus 4, and we get minus 10. Minus 10.125, okay? So this is a quadratic that opens upwards because the a value is positive. We know the y-intercept is at minus 4, okay? The y-intercept is at minus 4, and we know the vertex is at, where'd it go? Negative 1.75 and negative 10. Okay, so it's going to look something like this. Cool? So the range for this is going to be y can be anything except it has to be greater than negative 10.125. Okay? The next, what does it say? It says the intercepts. So the y-intercept is already given in the question. Y-intercept is just this value.
Yeah.
So that's minus 4. How do you find the x-intercept? Now for the x-intercept, you can factor this, right? You need to man this. You first need to factor it by using the man method. We're looking for two numbers that multiplies to negative 8, 2 and negative 4. That adds up to a 7. Any ideas? We're just trying to factor this quadratic.
Minus 8 plus 1.
Right, so it's going to be 2x squared minus 8x plus 1x minus 4. Okay, once you find the numbers, you just got to change the middle guy into those two numbers. Then you get 2x, x minus 4 plus 1, x minus 4. So it factors out to 2x plus 1 x minus 4.
Mhm.
So that means what are the x-intercepts?
Plus 4 and minus 1/2.
Right, there we go. The x-intercepts are at 4 and minus 1/2. Minus 1/2 and 4. Yeah.
Mhm.
And what else is going on here? The next thing it says is find the positive and the negative intervals. If you look at the graph, yeah, the positive interval is to the left of the x-intercept, right?
Mhm.
So that's -infinity to -half. The graph is positive. And where else is it positive? To the right of the x-intercept. In between the x-intercepts, all the values are negative.
Mhm.
So the positive intervals are to the left of this, which is -infinity to -half, and to the right of this. What interval would that be?
4 to infinity.
Right. And then the negative interval is between -half to +4.
Mhm.
And increasing, where is this increasing? It's increasing from the vertex, yeah? See here? From this
Mhm.
all the way up.
Yeah.
And the vertex was at -1.75, so it's increasing from -1.75 to +infinity, and it's decreasing at -infinity to -1.75. So to the left of the vertex, yeah, this part it's decreasing because the
Mhm.
graph is falling down, and to the right of the vertex, the graph is increasing.
Okay.
You understand that? This is just for the quadratic, okay?
Mhm. Yeah.
Now for the reciprocal function, look at this. The domain, yeah? The domain is everything except the zeros. So the domain for this reciprocal function is it can be anything, but it cannot be -half and +4, because if they were to be these two numbers, you'd get a 0 in the denominator.
Okay.
What's the range of this reciprocal function? The range of a reciprocal function is always that y can't be 0.
Okay.
So y is everything, yeah?
Mhm.
Actually, if you look at this, what would the range look like? So it's gonna look something like this. You'll have this, you'll have this, and you'll have something like this. So y can't be 0. Okay.
Uh-huh.
The x-intercept for a reciprocal function, it has no x-intercept because there's an asymptote, a horizontal asymptote on the x-axis for a reciprocal function. Okay.
Mhm.
To find the y-intercept of the reciprocal function, we can just plug x as 0, or we can just flip this y-intercept. It's gonna be at 0 and -1/4. Just turn this upside down. Or you can plug x as 0, you'd get the same answer.
Mhm.
And then, now this thing is helpful. The positive and the negative intervals for the main function and the reciprocal function is exactly the same.
Okay.
Okay, so the positive interval is this and the negative interval is this, also for the reciprocal function, but the increasing and decreasing intervals, they flip. So that means, what does that mean? That means the reciprocal function is increasing between -infinity to -1.75, okay?
Mhm.
And it's decreasing at -1.75 to +infinity. So the increasing and decreasing intervals, they flip.
Mhm.
And there we go. And we can sketch this. I mean, I already kind of made a sketch. It's gonna look like this. If you have a quadratic that looks like this, yeah,
Mhm.
your reciprocal function, how do you sketch that? Step 1, draw the vertical asymptotes. Whenever there's a 0 in the main function, the reciprocal function is gonna have vertical asymptotes.
Mhm.
And then this portion is gonna look like this. The one on the left is gonna look like this. And then this one will look like this. This, like that. And there you go. That's the reciprocal of a quadratic. Okay.
Okay.
Yeah, this one was a little bit tricky. Usually it'll be for a linear. For a linear, it's much easier. For a quadratic, you have to find the vertex, and then it'll have multiple vertical asymptotes, unlike a linear.
Mm-hmm.
Let's do another question here. This one's now they've given us a graph, and we need to draw the reciprocal of this function. How do we do that? We want to graph 1 over f of x.
So we could like grab whatever information we see from the graph.
Yes. The first step should be to draw out the vertical asymptotes, okay?
Okay.
Whenever there's a 0 in the main function, there's going to be vertical asymptotes in the reciprocal function, because that will give us a 0 in the denominator.
Mm-hmm.
So there you go. That's the first step. The next step, I guess, you can just find the y-intercept. You see the y-intercept here is like -12.
Mm-hmm.
So that means the y-intercept for the reciprocal function is going to be 1 over -12,
Mm-hmm.
which is like 0.1, right? It's all the way up there.
Yeah.
And once you have that, again, a quadratic is going to look something like this. It's going to go up there, yeah,
Yeah.
like this. And then there's going to be this on this side and this on this side.
Okay.
Does that make sense?
Yeah.
So how do you flip this? Step 1, just draw the vertical asymptotes.
Mm-hmm.
And then flip the y-intercept. And actually what you can do is, if you want to be a little bit precise, you could use multiple points. So I flipped this. 1 over 12 is like -0.1 approximately, yeah?
Mm-hmm.
But there are some nicer points that you could flip. You see this is 4, -4.
Mm-hmm.
1 over -4 is -1/4, so that point is going to go all the way there.
Mm-hmm.
This is 2. 1 over 2 is -1/2, so that point is going to go there. You see that?
Yeah.
And then same thing on the other side, like that. -4 would end up here. So actually, more precisely, your graph would look something like this down there. So there you go. That's what it looks like, okay? Even here,
Mm-hmm.
you can kind of pluck a few points. You see, that's 1 or whatever. 1 over 1 is 1. This is 2. So this is going to become 0.5, you see?
Mm-hmm.
So it's going to look something like this. And this is as precise as you can be. Same thing on the other side. And there you go. Okay?
Okay.
All right, let's do this one. So now this one's asking you not to sketch it, but to find the equations of vertical asymptotes, horizontal asymptotes, and holes, if any. Well, let's look at the first one.
Okay.
Where's the vertical asymptote, if there is any?
-17.
So the vertical asymptote is at x equals -17, yeah?
Mm-hmm.
Because it's an equation. What about the horizontal asymptote?
0.
Right, it's at y equals 0, right?
Yeah.
Because the degree of this is less than the degree of this.
Mm-hmm.
Are there any holes? There's no holes.
No.
Let's look at B. Where's the vertical asymptote?
-3/5.
Right, so x equals -3/5. Where's the horizontal asymptote?
0. Or would it be y equals 3?
No, neither 0 nor 3.
Oh.
So this one, right? Look, you got to look at the degrees in the numerator and the denominator.
Mm-hmm.
What's the degree in the numerator? It's a degree 1, right? There's a linear.
Yeah.
In the denominator, there's a degree 1 as well. So if the degrees are the same, the horizontal asymptote is the ratio of the coefficients, of the leading coefficients.
Oh,
So it's going to be at 2/5.
okay.
Because the degrees are the same, right? Same degrees, you got to take the ratio. In part A, the degree in the denominator one, that's why it's y = 0. Degree denominator, whenever this is greater than the numerator, you would have y = 0, the horizontal asymptote. If the degrees are the same, like in this case, 1 and 1, it's going to be at 2/5.
Mm-hmm.
And like if the degree in the numerator is higher, then there is no vertical asymptotes, which we'll do in part D. Let's do that right now. Actually, I think you can do part C. Yeah. Part D. Let's look at this one. Where's the vertical asymptote for that one?
+1.
No, see, that's wrong. Or is it? Actually, no, you're right. It is. It's not wrong. I thought we could factor this out, but we can't. So the vertical asymptote is at what? X = 1.
Mm-hmm.
What about the horizontal asymptote?
Well, when the degree of the numerator is bigger than the one in the denominator, what would you do then?
So when that happens, there is no horizontal asymptote.
Oh,
But there's a different type of asymptote now. It's called an oblique asymptote.
right. Okay, yeah.
And to find the oblique asymptote, you're going to have to do long
To
division.
divide, yeah.
Yeah. I'm just going to use synthetic. Okay. You know how to use
Okay.
synthetic division, or you know how to divide
Yeah.
well?
But my teacher doesn't suggest to use synthetic just because sometimes it doesn't work out.
It does not.
No.
All right, I guess we'll use a long division. The x term is missing, so I'm going to add a 0x.
Mhm.
What goes up here?
3x.
Right. So 3x times this is 3x squared. 3x times this is minus 3x, right?
Mhm.
Subtract them. This becomes a positive 3x, and we bring down the -2. So you just need a +3 up there. And then again, it doesn't really matter what we get down here because we're not interested in the remainder.
Yeah.
So our oblique asymptote is at y = 3x + 3.
Mhm.
Alrighty.
Yeah.
So that one is not that bad. Let's try doing some more guys. Guess we could do this one. So this one just says solve for x. And now this is not an inequality, it's just a
An
equation.
equation.
Yeah.
Yeah.
So what do we do here?
So first, wouldn't we try, well, like usually you would see if you could factor any further, but like you can't.
No, you can't.
So then wouldn't we find a common denominator or like a lowest common denominator?
Yeah, you could do that. Or you could also just cross multiply.
Okay.
That might be easier. So I'm just gonna multiply this with this and this with this. Okay?
Mhm.
So it becomes -4x minus 12 is equals to -4x squared plus 4x, like that. What do we do from here?
Then you can like collect all your like terms onto one side.
Yeah, so in fact, you have to move everything to one side because it's a quadratic.
Yeah.
So if it's degree 2 or up, you want to move everything to one side and make it equal to 0.
Mhm.
Now we solve this quadratic. Actually, we're going to pull out a 4, right?
Mhm.
Well, I'm going to do that. And two numbers that multiplies to -3 adds to -2. What are they?
Um 3 and 1.
Right. -3 and +1, right?
Yeah.
So that means this thing factors to x minus 3, x plus 1 = 0, right?
Yeah.
So that's going to be x is 3 and x is -1. There we go, you're done. So once you factor them, you can just set them equal to 0 to find the x-intercepts. Did you get that?
Yeah.
So an equation, it's easier because you can just cross multiply. Have you done any word problems?
No, he never gives us word problems.
All right, let's do some inequalities. All right, this one. Now we can't cross multiply because it's not an equation. How would we do this?
So first, wouldn't you bring them all onto one side and set it equal to 0?
Yes. So I guess we can just bring that to this side. Over x plus 3 is less than 0.
And then we multiply the minus x plus 5 with x plus 3.
Right. So negative x plus 5 times x plus 3 minus 1 all over x plus 3 is less than equal to 0, yeah?
Mhm.
Just less than. So I guess we can just FOIL out. That becomes minus x squared minus 3x plus 5x plus 15. Yeah?
Mhm.
So minus x squared plus 2x plus 15. Can we factor this? I think we can. We're looking for two numbers that multiplies to 15. Well, actually, there's a minus 1 as well. So minus 1 becomes minus x squared plus 2x plus 14. Can we factor that?
No.
Doesn't look like it, right? Only 7 and 2 multiplies to 14.
Yeah.
All right, so I guess that's it for this one. I'm just going to replace this guy with what it came out to be. Minus x squared plus 2x plus 14. Okay.
Mhm.
Now what do we do?
Um
So you got to find your critical values, which is basically the list of all the asymptotes, the vertical asymptotes, and the zeros.
Okay.
So you see this is a quadratic that opens upside down, has a positive y-intercept, yeah?
Yeah.
That means it has x-intercepts, okay?
Okay.
So you're gonna have to find those first. Since we can't factor it, the only way to find the x-intercepts is by using the quadratic formula. Yeah?
Okay.
X equals minus b plus minus b squared minus 4ac over 2a, where a is minus 1, b is 2, c is 14. Plug it in here, it'll give you the x-intercepts, right?
Mhm.
I'm going to do something because I'm lazy. To save time, I'm just going to put this in Desmos. Desmos, boom. X squared plus 2x plus 14. Or sorry, it was minus x squared. Boom. So those are our two x-intercepts, okay?
Mhm.
And you could have gotten this by plugging these three values into this formula, but I'm just going to save some time here. So what does this mean? This means our critical values from the denominator, we got a minus 3, right? From the denominator, we got minus 3, yeah?
Mhm.
And then from the numerator, we get these two. So when you're making the interval, the first one's going to be from negative infinity to negative 3. And then from negative 3 to negative 2.87. And then from negative 2.87 to 4.87. Yeah.
Mhm.
And then finally from 4.87 to positive infinity. Yeah.
Mhm.
Those are going to be our intervals. And then here we have minus x squared plus 2x plus 14 and x plus 3, and then f of x. Yeah.
Yeah.
So again, see, we have the graph here, so I'm going to use it. Between negative infinity and negative 3, this quadratic is going to be negative.
Mhm.
X plus 3, well, minus 10 plus 3 is negative. That means the entire thing is positive. Yeah.
Mhm.
And we're looking for less than 0, so we're looking for negative. Between negative 3 and negative 2.87, again, you can see this only becomes positive after 2.87. That means
Mhm.
this guy is negative. Here I can just plug in negative 2.8 or 2.9 here. This will give me a positive. That means the entire thing is negative.
Mhm.
Here, I'm just going to plug in the value of 0. That means the y-intercept is 14. This one's going to be positive. 0 plus 3 positive, so the entire thing is positive. And lastly, between 4.87 and positive infinity, this guy is negative, as we can see, yeah?
Mm-hmm.
It's going to give you a negative value, but this one will give you a positive value. That means the entire thing is negative. So our answer is between -3 and -2.87, and from 4.87 to positive infinity, because we need it to be less than 0. So
Okay.
these two intervals is our answer, okay? This one and this one. Does that make sense?
Yeah.
It's just a little bit tedious. I mean, the process. Yeah, this one was weird. Usually you can factor them out. That one was not even factorable. Let's try doing one more of these. Alrighty, another inequality. How do we proceed?
So first we'll move it onto one side
Right,
and
so
set it to 0.
you can move either one of them to the other side. It does not matter. So 3x plus 4 minus x over x plus 1 is greater than 0, yeah?
Mhm.
Gonna multiply this with this, so this becomes 2x squared plus 2x. Multiply this with this, becomes minus 3x squared minus 4x all over 3x plus 4 and x plus 1.
Mhm.
So this one, if you clean it up, it becomes minus x squared minus 2x over 3x plus 4 x plus 1, yeah?
Mhm.
Minus x squared minus 2x. So here you can just pull out a minus x, then you're left with x plus 2. Yeah?
Yeah.
That is greater than 0. There we go. That's what we needed. This one, they're all nicely factored, so we don't have to worry about using the quadratic formula, yeah?
Mm-hmm.
So your critical numbers are, I'm just going to plot this on this number line. It's at 0 because of this. It's at -2 because of that. It's at -1 because of this. And then it's also at negative
Negatives.
1.1, we have 4 over 3, yeah?
Mm-hmm.
-4 over 3. We can use that to make a chart. -infinity to -2, -2 to -4 over 3, -4 over 3 to -1, -1 to 0, and from 0 to positive infinity. If there's a lot of them.
Mm-hmm.
Oh, I don't mean to, I don't want to erase that. So again, here we have -x, x plus 2, 3x plus 4, x plus 1, and then finally f of x. Yeah,
Mm-hmm.
it's going to do this first. -10, or -10 positive, negative, negative, negative. The entire thing is negative. So I can plug in -1.5 here. This will be positive. This will be positive. This will be positive. This will be negative. Here I'm plugging in -1.5, so that's positive. -1.5 positive. Negative. So the entire thing is negative. Actually, this should have been positive here. Okay, we're just plugging in the values.
Yeah.
Here I'm plugging in -1.5. Let me see if I did that right. That's right. -4.5 plus 4 is negative. Yeah, this is good. So from here, I'm going to plug in -1.25. This will be positive. -1 that's going to be positive. This is going to be negative, so the entire thing is negative. I'm going to plug in -0.5. Positive, positive, positive. The entire thing is positive. And then this one will be negative, positive, positive, positive. The entire thing is negative. So we have 3 different answers here. Actually, no, we need it to be positive. So it's here and here. And there we go. That's the answer. Because we needed it to be positive at the bottom, greater than 0. Okay,
Okay.
you're getting this, right?
Yeah, yeah, yeah.
So just factor it, find your
The
critical
factoring
values.
tables help a lot because you can visually see where it's like where you need it to be, whether it's positive, like greater than 0 or less than 0.
Exactly, yeah. So it's a powerful tool. I wonder how you would do this. So it says when is g of t? This guy, yeah.
Mhm.
Multiplies to 7, adds to 8. It's just 7 and 1, right? Multiplies to 7, adds to 8. Yeah. So I just factor this denominator,
Yeah.
and then we have to subtract that guy, right? 40t. Like that. And now what do we do?
So now we just multiply the denominators.
Yeah, this is gonna be tedious. I think this was supposed to be a calculator question. What if we graph this? Because you see, this is gonna give us a cubic, because we're gonna multiply both the t's here. We already have a t. So this is gonna get really tedious. I don't know if you can do this by hand. I think this was supposed to be like a calculator problem. Let me plug this in. 40 over x squared plus 1 and 45t or 45x over x squared plus 8x plus 7. And we want to know when the blue graph is greater than the red graph, okay?
Mhm.
When is the blue graph greater than the red? What would be your answer?
At is that 1?
So
Like,
the blue for a fact is greater. Yeah, it's above the red one here. Yeah.
yeah.
So it's from 3.306 to positive infinity. Yeah, right.
Mhm.
And where else is the blue one bigger?
At negative, I think that's -1.
Right, it is -1 because we have an asymptote there.
Yeah.
So from what to -1 though?
40.
From -40 to -1?
Like, hold on. We're talking about where it's greater.
So for what x values is it greater? So you have to say it in terms of the x values. Yeah, here you see the blue is greater than the red, yeah? From 3.3 to positive infinity, right?
Yeah.
So we know the blue one has two different asymptotes. There's one at -1, and then we factor this, right? There's one at -7 as well.
Mhm.
So you see this is, so there's an asymptote here at -7, and then there's an asymptote here at -1. So
Yes.
the blue one is bigger between -7 and -1.
Oh, okay.
See right here in the middle,
Yeah.
between the two asymptotes, the blue one is bigger. So it has two different answers, this one.
Okay.
Yeah, this one, I don't think you can do this by hand because the x-intercepts are not nice. Usually if it's a factor by hand question, then you'd get nice points of intersections, but that one we didn't. Just gonna leave this down here. I don't think you have done rates of change, right?
No.
I mean, this one's pretty simple. Or is it? Ooh. So which one is which? Which graph represents which equation?
So for A, it's like for graph A, it's with B, and for graph B, it's with A.
Right. What gave it away?
The asymptotes, the vertical asymptotes.
Yeah. That's a very simple question. Yeah, this is a good question. It says, without using graphing technology, sketch the graph of this rational function. So we need to make a sketch of that. And we can't use Desmos here.
Mhm.
How do we do?
So we can start off, we know what the vertical asymptote is.
Right. Well, actually, you should factor this,
Yeah,
right?
I was just gonna say I think we can factor.
You always factor just in case they cancel out and you get a hole. So we don't cancel them out here. So that's fine. So we know the vertical asymptote is at x equals 2, right?
Mhm.
Where's the horizontal asymptote if there is one?
0.
No.
Oh,
Look at the degree, right? The degrees are the same, so it's not going to be a 0.
oh, okay. So then it's gonna be a
So
2.
exactly.
Yeah.
2 over 1, 2. So we have the vertical asymptote, we have the horizontal asymptote. We can also find the y-intercept and the x-intercept. So the y-intercept is when x is 0, right?
Mhm.
So we get 2 times 0 plus 6 over 0 minus 2. It's at -3.
Okay.
And then the x-intercept is when y is 0. So we're going to set y as 0
Mhm.
and then solve for x. So 2x plus 6 over x minus 2. We can just multiply both sides by x minus 2. So we get 0 equals 2x plus 6. So x is -3. So both the x and the y-intercept are at -3.
Mhm.
All right, so let's just jot down what we have, and I think that should be good enough. So we know at x equals 2, there is a vertical asymptote. So and we know, what else do we know? At y equals 2, there's a horizontal asymptote. So 1, 2. Y-intercept at -3. X-intercept at -3 as well. 1, 2, 3. All right. That's what we have so far, right?
Mhm.
So again, this is a rational function, yeah? A rational function usually only has, there's one vertical asymptote. There's one vertical asymptote. That means this rational function has 2 parts, yeah? One vertical asymptote means the function is divided into 2 parts. And the only way this can work is if you have a line going through both the x-intercept and the y-intercept, you see, like that.
Mhm.
So that's the only way this can work. So if there's a graph going this way on this side, that means the other half of the graph must be up here in this quadrant. And there you go, that's the sketch.
Mhm.
I mean, if you want to be super precise, what you can do is you can pick a couple of points here as well, right? So when x is 3, so you get, I can just plug that in the calculator. 2 times 3 plus 6 divided by 1. So y would be 12. You see at 3, it's going to be 12, yeah?
Mhm.
Which is up there. And then you can just use these points to make the rough sketch. Okay?
Mhm.
So step 1, asymptotes. Step 2, intercepts. And step 3, if you need, you can plug in points. Here we didn't need to because this kind of gave the pattern away. All right, that wasn't that bad. Let me see if I can pull something up for you, Rational, because that's kind of the questions in the book. All right, I got something. These are all rational functions. Yeah, it is. Alrighty, this is a test basically. It says find the asymptotes, holes, intercepts, yada yada.
Okay. So the vertical asymptote is at +1 and -4.
Yes, but no. Again, always factor things out. It could be a hole, right? See the numerator, you can factor.
Oh, right.
What does the numerator factor to?
Um,
So it's going to multiply to -12. It's going to add to a 1.
-3 and 4.
Right, -3 and +4. So x minus 3, x plus 4. You see these canceled out?
Yeah.
So there's the hole at x equals -4.
Okay.
So the vertical asymptote, there's only one that's at x equals 1. Yeah.
Yeah.
What about the horizontal asymptote?
That's gonna be okay, it's either 1 or 0, and I want to go for 0.
No, it's not 0 because the look at what's left. Degree 1, degree 1.
Yeah.
Same degree. The ratio is 1/1.
1, 1. Okay, so then it's 1. Okay.
1. What else do we need? We need the. Oh, it says coordinates of hole. So you also need the y value of the hole. Yeah.
Okay.
To
So we
find
could
the
just plug that
yeah
into the.
yeah we just plug the x's. Whatever is left, we just plug that as -4.
Mm-hmm.
So that's -7 over -5. So it's 7/5. And we can find the y-intercept by plugging x as 0, right? So
Mm-hmm.
0 - 3 over 0 - 1, it's at 3. And then the x-intercept is when y 0. So this is 0. That means it's going to be at x equals 3. And there we go. 0 equals x - 3. So that means the x-intercept is at 3. If we wanted to make like a rough sketch, I can do that as well, right?
Mm-hmm.
Y-intercept is 3, x-intercept is 3. There's a horizontal asymptote at 1 and 1. All right, there we go. Now look at this. This kind of gives it away. That just these 2 points will give away the direction of the curve. So it's a rational function with one vertical asymptote. That means it's divided into 2 parts, yeah?
Mm-hmm.
And the only way this is going to work is if on the bottom part it went this way, and on the top part it went this way.
Mm-hmm.
And there we go. That's the sketch. Okay. Here's a concept question. It says, is this a reciprocal of a linear or a quadratic? And how do you know?
I'm gonna assume that it's a linear one.
It is a linear one. That's right. Because for a quadratic function, yeah,
Yeah.
it looks like this. The reciprocal is going to be either above the x-axis or below the x-axis.
Mm-hmm.
It's not going to alternate like it is here. This means that the function is odd degree. And if it's on the same side, that means the function is even degree. So this one has to be a linear one, okay?
Mm-hmm.
This one's kind of interesting as well. So they've given us the 2 graphs. The linear one is obviously the straight line, and then the 2 sections is the rational function.
Mm-hmm.
So it looks like there's an asymptote at -2. Yeah. There's an asymptote at -2, and there's an asymptote at +1. I don't know if that's useful, but. And the question is asking us, when is the rational function greater or equals to than the linear function? So when are the curves greater than the linear, the straight line?
Okay, so it's at -1 and 0.
What's happening at -1 and 0?
That's when like the curve actually intersects with the like line, and then it starts. Or wait, no, it doesn't.
It's not at -1 and 0. -1 and 0, yeah, is right there. That's
Or
negative.
no, sorry, I meant 0 and -1.
Yes, yes. So that's when the curves meet, yeah.
Yeah, that's right.
So we know the interest. So how would you answer this question? It's asking us when will it be greater than? So the solution, yeah, is when x is 0 to +infinity from here onwards. Actually, no, that's not when it's greater. It's less than there. So the curve is bigger, yeah, between this to 0. So between something and 0. You see this? Well, we don't know what that is, right? Where do they intersect on the x? Looks like it's 1.5, but we don't know where that is. We can find that out algebraically. Where do they intersect? By setting them equals to one another. See, I'm trying to find this point here. Because the curve is greater than the linear line between this point and 0 on the x, right? So to find this point, we're going to set them equal to one another and solve for x. I'm going to cross multiply 4x squared minus x plus 8x minus 2. Now I'm going to move everything to one side. So 4x squared, this becomes plus 7x plus 6x equals 0. Yeah, like that.
Yeah.
So the 2's, they cancel out. So how do we solve for x here?
Could we factor those?
Yes, we can. We can pull out a 2x.
Yeah.
So this means 2x is 0, x is 0. Well, we knew that. And that means 2x plus 3 is 0. That means x is minus 1.5. So this point is minus 1.5 on the x. So our curve is greater than the linear between negative 1.5 and 0. And they're both included because they're equal at that point, right? That's why there's a square bracket there. But that's not the only answer. There's one other interval when the curve is greater than the linear. It's to the left of the asymptote. You see from negative infinity to negative 2, you see this curve?
Yeah.
It's greater than the linear is all the way down there. So between negative infinity and negative 2. Now these are both can't be inclusive, okay? This is an asymptote and infinities are never inclusive. That's why they're in those rounded brackets. So that's where it's positive. So it wins to the left here. Yeah, this one wins. And between the 1.5 negative and 0, it wins as well. So that's the answer to this question. Is that good? It's not the kind of a tricky question. It says find the equation of a rational function with these characteristics. Any ideas?
No.
No ideas? All right, let's start with the vertical asymptote. It's at x equals 5. That means in the denominator,
X
we'll have some
minus 5.
5. Perfect. There we go, right? We have x minus 5 in the denominator. And we know the horizontal asymptote is 2, right? So that means the ratio between these two, there must be a 2 in the top, right?
Yeah.
There must be 2x minus something or plus something.
Mm-hmm.
I'm just gonna say 2x plus d. Now we know the y-intercept is 1/5, yeah?
Mm-hmm.
What would the y-intercept be right now? The y-intercept right now would be a 0, so that means this must be a +1.
Okay.
Right? Because when you plug the x as a 0, you need to get 1/5.
Mm-hmm.
And there we go. I think this one, the x-intercept will also be -1/2, because if you set it to 0, 2x plus 1 equals 0, so x will be minus 1/2. Yeah. Cool.
Mm-hmm.
So this one was a little bit tricky. Don't really want to do that. Okay, let's try doing this one. So they've given you this and they want you to find a possible equation.
Okay. Well, a possible equation.
Mhm. It's a little bit complicated again, right? Here, look at this. How do you start this? Always start at the vertical asymptote, yeah?
Mm-hmm.
Where's the vertical asymptote? Looks like it's at 3. So x minus 3 in the bottom for sure.
Yeah.
But now notice something else. What's happening here?
Um.
There's a hole, right? X minus 5.
Oh, yeah.
That means there must have been an x minus 5 on the bottom as well as on the top,
Okay. Yeah.
right?
Mm-hmm.
And now if you look at it, the x-intercept is at 1, right? The x-intercept is at 1. So what if we do x minus 1? Would that work? So this one gives us an x-intercept of 1. That's fine. And then finally, we have to check for this. When x is 5, the y value should be 3. 4 over 2, that's a 2. So right now what I have, I've used this information, I've used this, I've used this. I have this equation so far, okay?
Mm-hmm.
The only thing that's not working out is this one. When I plug x as 5 in here, I'm getting a 2, but I should be getting a 3, right?
Mm-hmm.
What does that mean? That means simply we need to multiply this by 1.5. Because 2 times 1.5 is a 3.
Mm-hmm.
So there we go. That's a possible equation for this.
Okay.
And I guess we can do this one as well. Let me just pull up this one actually. The first one's only worth 1 point. So there's an equation, cost in terms of pairs of genes. Okay.
Okay.
Part A says find the cost if there are 3,000 pairs of genes. This is a very simple question. Look at it. It's only worth 1 mark, right? So you just need to plug
Mm-hmm.
x as 33,000. So you simply find C of 3,000.
Mm-hmm.
So that's going to be 3,000 squared minus 7 times 3,000
Mm-hmm.
plus 30 over 3,000. And there we go. Actually, my bad. So again, these questions are a little bit tricky. It says in thousands, you see?
Mm-hmm.
So 3,000, I should have plugged x as 3, not 3,000. So I need to plug x as 3, okay, like that.
Mm-hmm.
And plug that in the calculator, whatever that is. All right. Part B says, it's just a rate of change question. All right, what if we modify this a little bit? Question for you. If the cost was $5,000, yeah,
Mm-hmm.
how many genes were sold?
Um. Wouldn't you just do the same thing?
No. Now you sub the y value as 5,000. Before we sub the x value, now we sub the y value. So it's a little bit more difficult.
Oh.
Okay, because x is the gene, so we don't know what x is. We need to solve for x. Like that. Okay.
Mm-hmm.
And then you multiply both sides by x. So we get x squared minus 5,007x plus 30 equals 0. I multiplied by x and then I move this to this side. Okay.
Mm-hmm.
And again, this is a very difficult question to factor. Don't even bother factoring this. You can just straight up use quadratic formula, okay? but because we're lazy, I'm just gonna plug this in here, see if it gives us a nice answer. 5000x plus 30. And again, you can do this by using the quadratic formula. Okay, I got that as one of the answers. Where's the other answer? The other answer is right there. So they would have sold 5,006 jeans,
Mhm.
okay, to make $30,000, or sorry, $5,000 cost. Cool.
Okay.
I mean, yeah, you're not really doing word problems, but I think the word problems in this unit is really difficult compared to the next unit.
Yeah.
But it's okay. You guys got to avoid the word problems altogether.
Yeah, I know.
Okay, I guess that is it for today then for
All right.
us.
Thank you.
No worries. I'll see you next time. And I'm going to upload the video to the same channel, okay? All
Okay, perfect.
right, take care now. Bye-bye.
You too. Bye.